Okay, so today is Tuesday, March 27th. We're going to talk about the hydration of salts. You should have just finished taking quiz 10.4, and we should have already corrected 10.2. 10.3 is assigned today. So let's go ahead and get on with the PowerPoint. So again, 10.4 quiz and assignment 10.3, we are talking about salt hydrolysis today. As a learning check before we get going too far, I would like you to, on the back of your green part of your notes, just take a second and arrange these acids from the weakest to the strongest. I'm going to give you 30 seconds. Go. Okay, that's been about 30 seconds. Let's see how you did. So the weakest would be the strongest base. Remember, our pH scale goes basically from 0 to 14, but we can go a little bit either side. And the lowest number is our strongest acid. The biggest number is our strongest base. So the weakest acid would be the strongest base, which would be C at 11.5. So we've used that one. Then we would go to E at 7.5. So we've used that one. And then we would go to A at 5.6, B at 2.3, and D at negative 0.12. This being our strongest acid, this being our weakest acid, but our strongest base and our weakest base. Okay, with A being, well, nope, with E being about as close to neutral as we can get with what we've given. All right, so let's go forward. As we talk about salt hydrolysis, that is putting salt with water. So, or it's putting something with water. When hydrolysis, you're talking about putting something with water. So here, if we look at metal oxides, metals are on the left side where we make our bases, where we have our 6 strong bases in the Tetris pattern. So if we add a metal oxide with water, it's going to make a hydroxide. All of these are bases. Okay, the 3 that are listed right here happen to be in our Tetris pattern, which is our strong bases. But we could make a base that is not strong or is not as strong. For instance, we could make rubidium hydroxide or cesium hydroxide or beryllium hydroxide. They would still be bases. So let's look at what happens if I use the other side of the periodic table. This is where we get our swooping down in our acids. So if I use a non-metal oxide, a non-metal oxide, when it's mixed with water, will give us an acid. Here, H2SO4 is one of our strong acids. If we look at the next one, CO2 and water gives us carbonic acid. Remember, it actually goes more that way because this one is a weak acid and it doesn't like to go forward. So this one is a weak acid. On the next one, we get phosphoric acid, and again, phosphoric is a weak acid. So we still get an acid, but it's weak. Next one down, we get sulfurous acid, again, a weak acid. And the bottom one, we get 2 nitric acids out of there. I could have written it as 2HNO3 instead of like I did. But that is a strong acid. So we have on here 2 strong acids with the rest weak. But when I have a non-metal oxide and I mix it with water, I am going to get an acid. So metal oxide, water, base, that's on the left-hand side. Non-metal oxide on the right of the periodic table with water will give you an acid. So I'm going to give you another minute here for a learning check to see if you remember how to do the titrations. This one is a 1-to-1 relationship. You remember that? I'm going to give you a few minutes just to write that down. So if you'd pause the video for a second, give them about a minute, and then come back. Okay, so let's see how you did. Remember, you should pull everything you've got out of the story problem, because story problems are there to make you messed up. So I'm going to use MAVA equals MBVB. Okay, and since I've got the number of acids is equal to the number of hydroxides, I don't have to put those in. So my VA is 7.5, my MA is 0.5, my VB is 10, and my MB is what I don't know. So I'm just going to plug things in. Again, this is I'm solving for my MB, and I divide both sides by 10, and I would end up with this for the answer for my molarity of my base. I like to use acid and base because then I keep track instead of the M1, V1, M2, V2. So here's another one I'd like you to check. Again, I'd like you to pause the video for about 2 minutes, give them about 2 minutes, and then bring it back. Okay, so let's go ahead and bring it back. Let's see what you did. Again, pull things out. Molarity of the acid, volume of the acid, molarity of the base, volume of the base. This is hydrochloric acid, which is HCl, 1 hydrogen, 1 hydroxide, so I don't have to worry about that. Plug in, solving for MA, and we get 0.17 molar. How'd you do? Thumbs up, you got it. Thumbs down, you didn't. If you didn't, look around for somebody with a thumbs up. Have them explain that to you. Okay, so 2 amphoteric substances. Remember, amphoteric means it can act as an acid or it can act as a base, depending on who it's with. Here are some examples that you could have put down. It just needs to have, water is the most famous amphoteric substance, but the others just need to be able to gain a hydrogen or lose a hydrogen. So when we have a weak acid or a strong acid that's lost one hydrogen already, it could gain a hydrogen back or lose a hydrogen. Notice after that, I'm just taking oxygens away and making different ones there. So as long as they've got 2, or as long as you've written down 2. And what makes a buffer? A buffer is made of a weak acid or a base and its salt. So how'd you do? Hopefully these are getting into your head. These are things that you'll need to know for the test. So let's go ahead and go forward here. Didn't have a lot of notes for you today, about 10 minutes. So you should be able to finish assignment 10.3 fairly quickly and be able to get a stamp that says you have completed the work for today. Remember, that gives you an extra credit point on your assignment.